Right, good morning, boys and girls and anyone else, okay? Mr. Leshem is here and we're going to try and tackle this business about horizontal shift, okay? I'm going to start with parabolas, but actually it's true for all the kind of functions we've got, okay? So last lesson we did a quick recap and we realized that y equal x squared is our mother graph for these shapes called parabolas, okay? It goes to the origin, 0, 0. When x is 1, y is also 1. So I'll write down 1, 1. And also minus 1, 1. And when x is 2, let's say here, 2, the answer, y is 4. Okay? We always square this, okay? Now, what I did ask you to at the end of last lesson is to just sketch this graph. Y is x plus 1 squared. So we added to the 1, I mean, it's not y equal x squared plus 1. We dealt with these things and we know that's a vertical shift, it's just shifted up. What we're adding here is that plus 1. And you guys did that, okay? And what you got is a graph, a parabola, that was shifted to the left. It was shifted to the left. You just did it by sketching it, okay? So now the minimum, okay, we call this the minimum. Did I use that word minimum before? But it kind of makes sense, right? That's the minimum, it's the lowest point. Okay? Here it used to be 0, 0. Now it's minus 1, 0. Okay? Everything moved 1 to the left. Okay? When I had this point, now is going to be, when I put 0 here, it was 1 square, so it's 0, 1. Everything just moved 1 to the left. We call that a horizontal shift. Okay? I'll pose this a question. So, following from Leon question, okay? If this is a horizontal shift to the left, it will be interesting to know what will be the function that will shift to the right. Okay? So I'm going to first of all draw it. It's going to look like this, right? And my question for you, what will be the function now? Jack, you want to say?
Y equals in brackets x minus 1 brackets squared.
100%. Okay? So, exactly, alright? If you want a shift to the right, then it's going to be negative. It's a little bit opposite to kind of our intuition or common sense. Whenever you have a plus, that means you're moving to the left. Whenever there's a negative, it means you're moving to the right. Okay? There is a way of explaining it, and maybe I will explain, maybe not, but the most important thing is that you remember it. There's another question here. So, before I try and maybe explain why is the case, let's just try and look at some more simple functions. Oh, let's put it this way. Yeah, okay, let's do it like that. Let's say I want to shift it 2 to the left. So, I want the minimum to be not minus 1, 0, but minus 2, 0. And my question for you, my friend, is what will be the function? Can you try and guess what will be the function if I want to shift it to the left? So what should I write? Plus 2. What? Just plus 2? X plus 2. Square. Square. And you're excited and you have some life and well done. And hang on, I should have said this is 0, 1, okay? And now I'll give you another final question on this, okay? Let's say I have y equal x plus 3 squared. How are we going to draw that? No, I want to actually minus. You know, let's do a minus. X minus 3 squared.
To the right.
So it's going to be to the right how much?
3 times.
3. So where will be my minimum now? Which coordinate? Not 0, 0, not 0, 1.
0.
I'm just realizing I made a mistake here. This shouldn't have been 0, 1. What should that have been?
0 minus
1, 0.
1, 0. Thank you. Okay? Right? So what will be the minimum here? 3, 0. It moved 3 to the right. Okay? Minus moves to the right. A plus moves to the left. That's pretty cool. Okay? Now, am I going to try and explain it? I'm not going to try and explain it. Let's keep it simple, yeah? Yeah. Let's keep it simple. Okay, cool. I'll pause here for you to write it down. Guys, guys, once we've learned the principle, now we can do some examples. And actually one of them we already started. Okay? Again, you don't have to write that down. It is in page 55. Okay, this is page 55, example 1, I imagine. Yeah, or example 2. Example 2. So they ask us to plot this parabola. It is a parabola. How do I know it's a parabola? I don't know it's a parabola because it's squared. Anything that is squared means it's a parabola. But we already know that we had to shift the mother graph to the right. You guys said that, so I'm going to just plot it again. It's going to be something like this, and we know that this point, you guys told me, is 0, 3.
Yeah.
Not 0, 3. Why am I making that? 3, 3, 0. Okay, how do I know? Okay, because when I put 3 here, think about it. When I put 3, what is 3 minus 3 squared? 0. So that's why it's moved 3 to the right. Okay, the mother graph, okay, here I'm explaining to you a little bit why it's shifted to the right. The mother graph was y equal x squared. When x is 0, y is also 0. Here y will be 0 only when if I put x equals 0, 0 minus 3 squared, it's not 0. What does x have to be for this whole thing to be 0? 3. If I put 3 minus 3, it will be 0. Does that make sense? So everything moved to the right. Now, when you asked in a test to plot it, that's good. That's 1 mark for the minimum. You got 1 mark for the shape. There's one more thing you need to do, and you should know it maybe. You need the intercept. So there's one more intercept. This one. I need to find another one. It's so easy. Yes. All you gotta do, you sub 0 and x, right? Because that's what y-intercept, right? So you write y equals 0 minus 3 squared. You don't even need to do the whole thing. I'm just doing it now. That's minus 3 squared in brackets. And you write is 9. So I should put here 0, 9. And I have to write down the whole coordinate. Okay? I'll pause and answer. There's a question here. Yeah. So, chaps, all we're really doing now, we're learning to sketch graphs with a horizontal shift. So we're looking at all the families of all the graphs that we did last year, and I reminded you a little bit in the last lesson, and we're just adding that vertical shift, horizontal. So what family of graphs does this belong to? That's the hyperbola. Whenever you have divided by x, there's x at the bottom, that's a hyperbola. And to get to what we asked to do is to sketch this. And the best way of doing it is to go in, like they did in the book, in my opinion, to do a certain process. We always start the process with the mother graph. What is the mother graph of a hyperbola? Y equal to 1 over x. And you just need to remember the shape of this. It's this thing. It's very distinctive. Okay? Right? We've got 2 asymptotes, okay? A vertical asymptote and a horizontal asymptote. Okay? The horizontal asymptote can be described by the line y equals 0. That's the line y equals 0. And the vertical asymptote can be described by x equals 0. X everywhere here is 0. Okay? Now, the next thing we need to do is, instead of having 1 over x, let's add that minus 6, okay? So y equal minus 6 over x. That's kind of answering your question that you asked me, Finn. It was about parabolas, but it's the same effect. Okay? It will be on the hyperbola. Whenever you have a negative number, you time by a negative number, what does it do to our mother function or any other function? What does it look like? Everything gets flipped, inverted, reflected. The word is reflected around the x-axis. So this line that was here goes to this, so it's going to be like this. That's whenever we multiply it by a negative number. And then this line goes up like that. So we still have the same asymptote, it just all flipped up. What does the 6 do? It stretches it a bit. So instead of being like that, really, it's going to be even more. So it's a bit more slopey. But we're not going to worry about that right now. We will do it at the end. We'll come back to that later. Okay? Now the last, so that's the first you can say transformation from there to there. Now finally, what do I need to change here? +2. So I need to move on to y equal minus 6 x plus 2. Now what did we say happens? No. Okay, we're in the business of horizontal shift, right? It's x, so instead of x, we've got x plus 2. So what will happen to this graph now? It's going to shift to which direction? To the left, because it's positive. How much is it going to shift? 2. Minus 2. So, okay, the way to draw hyperbolas is to start by drawing their asymptotes. That's the best way. So, if this whole thing moves to the left, the y asymptote, the horizontal asymptote stays in the same place. Okay? But what happens to a vertical asymptote? 2 to the left. So now the new vertical asymptote is going to be there. It's not going to be x equals 0 anymore. It's going to be x equals 2 minus 2. So it's to the left. Right? Minus 2. Because this is minus 2. So move to the left. Okay. Now all I'm doing is drawing the same graph with blue, along these asymptotes. So it's going to be like that. Okay? Right? Now why did I draw the asymptote first? Because the asymptote is like the frame. Everything is around that frame. Can you see that? Okay? Okay? Okay. We're not finished yet. We're not finished yet. There's one more thing I need to do on this graph. Okay? The shape is right. The asymptote, I labeled the asymptote. I should label the asymptote. I should say that this is x equal minus 2. I should say that this is y equals 0. But I'm missing one detail. What is that? The intercepts. Do we have any x-intercept? Are we crossing? No, because the asymptote ensures, and we always get closer, that we never cross it. But we do have a y-intercept. Okay? How am I going to find the y-intercept? Substitute what? 0 instead of x. So I'm going to write y equal minus 6, 0 plus 2, which is minus 6 over 2, which is? Negative 3. So this point, my friends, is 0 minus 3. And we are done. With this example, we've got other examples. I'll just pause. There was a question about vertical shift. What if I wanted to push it up? What we learned last year, because we actually did it last year, the vertical shift will be, tell me how much you want to shift it up. +2. So it's going to be +2 here. Okay? Next lesson we're going to look at like horizontal and vertical shift, everything mixed together. Today we're just focusing on horizontal shift, okay? Right, take a minute to digest that and we're moving on to the next problem. So the last example is concerning exponents. So what our mission is to sketch this graph. Y equals 3 times 2 to the power x minus 1. Now, I'm just thinking about that. Can I just simplify to say 6 to the power x minus 1?
No, sir.
No, of course not. But why not?
Not the same.
What did I violate? What did I do which is really, really wrong?
Times in 3 times.
Bod mass, guys. Bod mass. So power comes before multiplication. If I multiply to 6, basically what I said is let's multiply 3 times 2 and then do the power. Please don't do that. Please. Okay? Right. So we start, as always, we start with a mother graph. The mother graph that I told you in exponent, okay, I would use y equal 2 to the power of x. That's the one I normally use. Okay? And 2 to the power of x, if I use something that is larger than 1, it's an airplane that is taking off. We spoke about that last time. Remember that one? And we also know what the y-intercept. When I put x equals 0, what do I get here? 1. Good. Now, let's introduce. Leave that as y equal to the 2 to the power x. I'm just going to multiply the 3. I want you to see the effect of what does it do when we multiply by 3. Okay? Now, 3 is a positive number, right? It's not negative. So it's not going to flip it. We're not going to flipping it. It's still going to go up. But the 3 just stretches it. It stretches, makes everything bigger. So when it went from 0, 1, it crossed through 0, 1. If I put 0 here, what will be y equal to? 2 to the power 0 is still 1. Times 3 is 3. So it's going to go through 0, 3. Can you see that? It's just going to be stretched. It's going to stretch it up. The airplane is taking off quicker. You happy with that?
Yeah.
Okay, if you've got a question, please ask, okay? Last thing, I'm adding that x minus 1. So instead of x, I'm going to x minus 1. Y equals 3 times 2 to the power x minus 1. Okay, what did I learn? If I'm going from x to x minus 1, what am I doing to this graph? Shift, horizontal shift to the right. How much? 1. So everything is going to move to the right. So it's still going to look like this, right? But this point, which was 0, 3, is going to move to become 1, 3. Right? It's going to go through 1, 3. That point is going to go to there. That point is going to go to there. Can you see it? Everything is moved to the right. If you don't get that exactly, don't worry. It's actually not the end of the world. What is more important? What is more important? What do I need to sketch? Actually, I don't need to add that point. But what point I do need to sketch here? Label.
Asymptote.
Actually, let's start with asymptote. You're right. We do have an asymptote. And it's this, what you call it, the horizontal asymptote, y equals 0. But what did you say, Simon?
The intercept.
The intercept. We only have y-intercept here. Y-intercepts are easy to find. What do I do? Y equals, what do I do? How do I find the y-intercept?
0.
I put x equals 0, right? Okay, so it's going to be 3 times 2, 0 minus 1. 3 times 2 to the power minus 1. How much is that? Without calculating, can you figure out?
Isn't it just 3?
Minus 6.
What is 2 to the power minus 1?
It's
No,
2 to the power
1.
minus 1 is 1.
0. 0.
no, 2 to the power 3 over 2.
No, Mike.
You're right. Okay? 2 to the power minus 1, reminding you from, I don't know what, grade 10 or grade 9, that's half. So 3 times half is 3 halves, or 1.5. Okay? 1.5. So here it's going to be 0, 1.5, or 3 over 2. Let's write 3 over 2, it's nicer than 1. Okay, then we're done. We're done. Okay, let's work. Cheerios, bye-bye.